students, the purpose of this video is to get you comfortable with measures of variation. The very first measure of variation is the range. The range is simply the difference between the lowest and highest values. So for example, in your class, if I were to ask, what is the range of abilities in regards to cooking? I'd basically be asking, who knows how to cook really well versus, who doesn't? Maybe who is a beginner level cooker, and what span of abilities do we cover in our class? What range of abilities do we cover? So it's simply the difference between the lowest and highest values. So in data, I'm going to list out all my values in order. I'm going to look for the highest value, and I'm going to subtract off the smallest value, and that is going to give me the range of my data. So looking at this example, I have the values 4, 6, 9, 3, and 7. The smallest value is 3, and the highest is 9. So I do 9 minus 3, and I find out that I cover a range of 6 values. Now, you can have misleading information at times. The range may not always be a great representation of what you actually have. For example, if you look at this data set that I have on your screen, one of those data points is what we call an outlier. It's extremely inconsistent with the data that we already have. Therefore, when I use that as my largest value and I subtract off the smallest value, it really truly throws off my range, when in reality, my values seem to be around 5, 6, 7, 8, 9, 11. They're more in that area than they are covering 3,611 values. So outliers can heavily affect your range. The standard deviation is a measure of how spread out our numbers are. We represent standard deviation using the symbol that you see on your screen. This is the lowercase Greek letter for sigma. The formula is very easy. It is the square root of the variance, meaning you need to know how to find your variance first. The variance is simply the average of the squared differences from the mean. So you'll find the mean, you're going to work out the mean, and then for every number, you'll subtract the mean and you'll square the results, and then work out the average of those squared differences. So it sounds a little confusing when I word it like that. So we're going to work through an example, and hopefully that will make it a little easier to understand. So you and your friends have a bunch of dogs, and you've decided to measure their height. So you see I've placed the dogs on the graph, and the red bars on their back represents the height at which we determine their height is. So that's based off of their shoulders. And you get 600, 470, 170, 430, 300, and measuring in millimeters. So you want to look for the mean, the variance, and the standard deviation. So step 1 is going to be to find the mean. So we know that mean is average, which means add up all your values and divide by the number of items that you have. So the values for the dogs are 600, 470, 170, 430, and 300. So I'm going to add those all up, and then there's 5 values, so I'll divide by 5, and I end up getting 394. So that is my average height. So when I go to my step 2, I'm going to plot using that green line where my average is located. And now what I want to do is I want to figure out what is the distance that each individual height is away from the mean. And so you'll see that I have these arrows here, and I'll highlight it in yellow to make sure you're looking at the right thing, which is showing the distance between the height from the mean. So I'm taking an actual height and I'm subtracting off the mean value. So I get 206, I get 76, I get negative 224, I get 36, and then I get negative 94. And once I've done that, I'm going to take all of those values. So again, what I'm highlighting here are all of the differences, right? So the differences that I just found. And then I'm going to square them. So this is the new part. I'm going to take each of those and I'm going to square it. And what that does is it turns my negatives into positive values and gets me new values. And then I am dividing it by the number of values that I have. So that is 5, because there are 5 individual values. And when I do that, I get 21,704. So notice the notation is sigma squared. And again, this is representing your variance, which we find as 21,704. And since I have a square, we know that in order to get rid of a square, I'm going to have to take the square root of that value. And if I take the square root of that value, which is square root of 21,704, I get approximately 147. So my sigma is equal to 147, which represents my standard deviation. Now, standard deviation is very useful. Now we can show which heights are within one standard deviation of the mean, and then which ones are even more than one standard deviation. So it creates a standard way of knowing of what would be considered normal and then what would be considered like extra large or extra small. So our first dog, the red bar right here, I'm highlighting it in blue, is higher than the one standard deviation, the blue line, so I would know that he's extremely tall. And my little bento over here, which I'm highlighting his bar, he would be below the standard deviation, so he is short. And for the population standard deviation, you'll divide by n because you're looking at the total, but for the sample standard deviation, you divide by n minus 1 because you are looking at a subset. For everything that we'll be working on in this particular class, we'll be working with the population standard deviation rather than the sample standard deviation. But in the event that you were to see a sample standard deviation, so if we were told that these 5 dogs were just a sample of the bigger population, then we would do n minus 1, so 5 minus 1, and we would divide by 4 instead of dividing by 5. But again, you're not going to have to worry about that in this course. So these are our mathematical formulas in order to find the population standard deviation as well as the sample standard deviation. They look a little complex, a little rough, but just think about the steps that we just named, and that's all you have to use in order to find your standard deviation. Now we do have another item called the coefficient of variation. It is a measure of relative variability, so it is the ratio of the standard deviation to the mean. The coefficient of variation is particularly useful when you want to compare results from 2 different surveys or tests that have different measures or values. So let's pretend that you're comparing the results from 2 tests that were scored a little differently. So your first test has a coefficient variation of 12%, and then the second test, which was scored completely differently, has a coefficient variation of 25%. So you would say that sample B has more variation relative to its mean. So it just allows you to compare 2 things that were maybe calculated a little different. Okay? Alrighty, well that concludes this lesson. I know that standard deviation and variation are probably a little more challenging to comprehend, and that's the case as well in a statistics course, but remember we're doing a brief overview, so we're not going too in-depth, but if you do pursue an actual statistics course, you'll talk more about the benefits and why you want to find standard deviation and why you would want to find the variance, and you'll begin to see across multiple data sets the benefits of these 2 measures. As always, I hope you found this video helpful. If you have any questions or concerns, please do not hesitate to reach out, and have a wonderful rest of your day.